Welcome to our next session, which is going to focus on how EGLE uses MiCorps stream data. I'm going to get us started, and then some other speakers will join me. Please put your questions in the chat or in the question and answer box, and then at the end of the presentation, if we have time, we'll address as many as we can. So, as Paul said, my name is Tamara Lipsey. I am the EGLE representative of our much larger MiCorps team. In addition to, hold on, I'm just gonna close something here. In addition to leading the program at EGLE, I'm also an aquatic biologist and I conduct water quality sampling across the state. And as I said, I'm the first of three speakers for this session, and I'm going to get us started. Just a quick review of the structure of the MiCorps program. So the MiCorps program is the umbrella for three different programs: the Cooperative Lakes Monitoring Program, the Volunteer Stream Cleanup Program, which Paul talked about, and also the Volunteer Stream Monitoring Program, which is what we're going to focus on today. A few years back, we focused on how the Cooperative Lakes Monitoring Program data was used both at EGLE and the Department of Natural Resources, so we thought we would focus on stream data this year. I have a couple of slides to introduce the Volunteer Stream Monitoring Program to the audience in case there's some of you out there who aren't as familiar with it. And then I will talk about how biologists use the Volunteer Stream Monitoring Program data in determining the water quality of Michigan's rivers and streams. Next, Teresa Salveta will talk a little bit about how stream data is being used in our targeted monitoring request process. And then finally, Jack Cotrone will talk about how a MiCorps volunteer stream monitoring group was essential in collecting additional water quality data in partnership with EGLE. So the Volunteer Stream Monitoring Program is primarily a grant program. Approximately $75,000 is given out per year in grants. We have three types of grants. We have the startup grant, which just helps people get familiar with the program and see if it's something they want to continue participating in. And if so, they can apply for a much bigger implementation grant. Usually they're watershed groups and conservation districts who apply for these grants and plan to continue to run a stream sampling program in the future. And then we also have a maintenance grant, which then helps groups continue to replace equipment if they need, maybe provide some staff time for entering data because the data is most useful when it's entered into our database. So it's a train the trainer type of program where we provide training to these leaders at the different watershed groups. And then these organizations then train their own volunteers year after year. And both macroinvertebrates and habitat are collected as part of the program in May and October. Just a quick note for some of our newer audience members who might not know what a macroinvertebrate is. They are organisms that do not have a backbone, and you can see them with just your naked eye. You don't need a microscope to tell that it is at least aquatic invertebrate or something. Most of them are aquatic insects or live part of their lifetime in the water. Some are snails or freshwater mussels that we have here in Michigan. The benefit of them is that they can be indicators of water quality because they live in a stream for weeks, months, or even years. And some are more sensitive to pollution than others, or they might be more sensitive to habitat destruction than others. If we take a water sample with a bottle and then send it to the lab, it only tells us about the pollution in the stream for that exact moment in time. Volunteers also collect information about habitat within the stream and along the edge of the river. And this information is important in understanding why we are seeing the macroinvertebrate community that we are seeing. Maybe the substrate type is not quite suitable, or maybe it is a water quality program and it seems to have great habitat. Habitat just adds to the story. Okay, so how do we use the MiCorps stream data at EGLE? It all starts with the Clean Water Act, which was a USA law that was most recently updated and passed in 1972 to help keep our rivers, lakes, and other surface waters clean and safe for people, fish, and wildlife. It also makes it illegal to pollute water by dumping harmful substances into a water body without a permit. And it all comes down to making sure the water is safe for swimming, fishing, and drinking water after treatment. To make sure each state is following the Clean Water Act, we here at EGLE are required to report to EPA how we're doing. So EGLE is the department for the state of Michigan that does this reporting, and every state has a different agency. Every 2 years, the Water Resources Division, which is part of the division I am in, uses the information we have collected the previous 2 years to create a report called the Integrated Report. It includes a list of water bodies that are not meeting water quality standards and are polluted or have degraded habitat. And this is called the 303D list for short. It also includes a list of all water bodies that have been assessed, like sampled it all, not just the polluted ones. And it gives us information on the water quality of each water body. And this is called the 305B list. And both these lists meet the requirements of Section 314 of the Clean Water Act, which requires states to identify the status and trends of water quality in our public lakes. So it's more detailed to lakes. So before I talk about the data that's used to make these lists, I want to talk about two other concepts: water quality standards and designated uses. So a water quality standard is a number, like it could be a concentration, or it's a statement to protect a water body for a specific designated use. So when I say it could be a number, it's usually a concentration, like a certain amount of mercury. I think it's 1.4 nanograms per liter. It's very tiny, is the limit that is healthy for our aquatic wildlife. Or it could be a narrative criteria. So it could say we looked at the health and the fish or the macroinvertebrate community indicates that a water quality standard is not being met. And these both are used to protect our state's designated uses. So what in the world is a designated use? It's essentially what we're trying to protect. And it goes back to the goal of the Clean Water Act to ensure all water is safe for swimming, fishing, and drinking. And these are the designated uses in Michigan that we use water quality standards to protect. The designated use circled is a lot of words to essentially say we need to protect aquatic life and other wildlife that depend on our water. And this designated use is where the MiCorps Volunteer Stream Monitoring Program macroinvertebrate data is used. Volunteer data is one important source of information that's considered when determining designated uses are being met. It's not the only one. We have a lot of monitoring programs here at EGLE, And we have data that's submitted by other people that we use to determine designated uses. So all of our biologists go out every summer and take macroinvertebrate samples as well. But the volunteer stream monitoring data can be one piece of the puzzle. The next integrated report that will be published will be coming next year. The locations indicated on this map are those that were sampled by MiCorps stream organizations, and then they entered the data into the MiCorps data exchange, and that data met quality assurance criteria, and it ended up being hundreds of data points. We used just the prior 2 years to the report that we're developing, so this data was the data collected between 2022 and 2024 by our volunteer groups. This is an example of what the summarized MiCorps volunteer stream monitoring data looks like. There's additional data for each type and number of macroinvertebrates that were identified. And we also have habitat data, which completes the story. But for slide purposes, I limited the number of columns I'm showing you. And this last column that I have highlighted in green is the water quality rating category that summarizes the count and identification data. So this information is going to be included with all the other data that EGLE staff has collected on rivers and streams, and will go into an EPA database called ATTAINS. And then the biologists will consider this data when they are reporting the water quality to put in those lists that I talked about. Here are some examples of what the EGLE biologists will see as part of the information they're reviewing for the lists. For the integrated report, I've included pictures of the flyers for each of the MiCorps organizations that collected the data, that then led to the macroinvertebrate community characterization. So the first one was from Friends of the Rouge. When the biologist for that watershed opens up the attains record for this stream, they'll see that volunteer stream data from Friends of the Rouge at Middle Rouge, which is their location, found macroinvertebrate communities characterized as fair, and then the date of October 2024 is there. The second example in the middle is from the Eaton County Collaborative, which is the University of Olivet and the Eaton County Conservation District. That biologist will see volunteer MiCorps data from Eaton County Conservation District at Lacey Creek, found macroinvertebrate communities characterized as fair, 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 fair. And so that shows that organization has been sampling that site. They sampled it in 2022, 2023, and 2024. And then the last example I have is from the Gogebic Conservation District. And that biologist will see that MiCorps data was collected at Wester Creek, that the community was characterized as very good in both May and September of 2024. So it's time for me to stop talking, and we will move on to another way in which we can use MiCorps volunteer stream monitoring data. And Teresa Salveta is going to join me, and I will let her introduce herself.
Thanks, Tamara. Good morning, everybody. My name is Teresa Salveta. I work in EGLE's non-point source program. I am based out of the Gaylord District Office in Northern Lower Michigan, and I cover 22 counties encompassed by both our Cadillac and Gaylord District offices. And Tamara, you're doing the slides for me, so we'll go to the next one. I first wanted to start with a summary of EGLE's non-point source program staffing. Our central staff, who are primarily based out of Lansing, serve as statewide program coordinators. They oversee development of standards and specifications for best management practices, coordinate non-point source efforts at the state level with other state as well as federal agencies, provide statewide education and outreach, and serve as grant project administrators for grants awarded by the Non-Point Source Program. District or field staff like me and my counterpart Jack, who will be presenting next, provide technical assistance at the local level. We're familiar with our region, its watersheds and water bodies, local organizations, and local water quality issues. We connect organizations and individuals working on non-point source and watershed management issues with non-point source central staff and other resources. We also provide guidance to grant applicants and grantees, provide oversight and assistance in watershed planning and implementation projects, and head up review of watershed management plans when they are ready to be approved. You can find more information about the Non-Point Source Program and locate this staff map that you see here and find out who your district staff person is or who some of those central staff contacts are by visiting our page on the EGLE website. The easy way to get there is just to type in michigan.gov/NPS for non-point source. We'll go to the next slide, please, Tamara. Just briefly, and probably an overview for most of you, non-point source pollution, unlike pollution from industrial facilities or sewage treatment plants and such, comes from many diffuse sources. For the most part, it is caused when pollutants are carried from the land and deposited into our waterways. But atmospheric deposition from air pollution is also a cause of non-point source pollution. Common types of non-point source pollutants include nutrients, sediment, petroleum products, salt, bacteria, and chemicals. These pollutants have harmful effects on drinking water supplies, recreation, fisheries, and wildlife. And according to the US EPA, states report that non-point source pollution is the leading remaining cause of water quality problems. A watershed management plan is a comprehensive plan designed to address water quality problems by identifying water quality threats and/or impairments, the causes and sources of the non-point source pollutants, and by providing pollutant load estimates. The plan provides strategies to address water quality problems by outlining water quality improvement and protection goals, information and education goals, identifying tasks to achieve those goals, and it also includes a monitoring and evaluation component to evaluate the effectiveness of the completed tasks. Next, MiCorps data can be used to assess watersheds and identify areas in need of further investigation. It can help determine other parameters that need to be assessed and be used to support targeted monitoring requests for additional assessment work by EGLE. I also want to note that participating in MiCorps is a way to share responsibility of assessing our waters with the state, and it shows your commitment to the watershed. So thank you for that. And next, the targeted monitoring request process. This process provides stakeholders such as members of the public, other state agencies, tribes, or even EGLE staff like myself, an opportunity to provide input on potential water quality issues, monitoring locations, and monitoring parameters for EGLE Water Resources Division staff biologists like Tamara to consider for the upcoming field season. Some examples specific for MiCorps volunteers. Perhaps there are some areas of the watershed that you're unable to assess and would like EGLE to evaluate the macroinvertebrates and habitat in those areas. Or maybe you're seeing a decline in stream health based on your assessments over time and would like EGLE to evaluate other parameters that may be contributing to the decline, such as nutrients, bacteria, or invasive species. For those interested in submitting a targeted monitoring request, we would encourage you first to reach out to either the biologist like Tamara for the watershed and or your district non-point program staff person like myself. We can help you determine what assessments have already been done by EGLE and which ones would be most beneficial for assessing overall watershed health and contributing to that integrated report that Tamara talked about. So there is a page on Eagle's website dedicated to targeted monitoring the process, the request process. I think I saw Paul put that up in the chat. You can also just type into your search engine Eagle targeted monitoring requests and find it that way. So when you visit that page, you can learn more about the process and you can also open the form to start submitting a request. New over the last couple of years, we now have a screening process that you will go through when you first open the form. That will help you determine if the data you're seeking maybe already exists, or if you're looking for something that Eagle may not be able to provide. Sometimes there are assessments that you have in mind that maybe is something that we don't provide. The screening process helps ensure that the requests that you do submit are more likely to be fulfilled. You can also work with the biologist or the district staff like myself to create and refine requests. And sometimes we will even submit requests on behalf of the public and partners we are working with. Some of the information you need in order to submit a targeted monitoring request includes the water body name, the specific location requested for monitoring, parameters being requested for monitoring, the concern or question you want the monitoring to address, or the objective that will be achieved by conducting the monitoring, as well as justification for the request. Targeted monitoring requests are typically due by the end of October in the year preceding the monitoring cycle. However, requests can be submitted at any time, and if you miss the deadline for something you really think should be monitored in the upcoming year, you should reach out to your district staff or the watershed biologist as soon as possible. We will typically evaluate and score the requests in February and March of the monitoring year, with decisions being finalized in May or June as the biologists work to finalize their work plans. And if you do submit a request, you will be notified whether or not that monitoring will be taking place in that monitoring year. So that's all I have, and I'll hand it over to Jack.
Thanks, Teresa. All right, I'm gonna move it forward. Jack, are you joining us?
I'm here. I'm good to go.
All right, Jack, go
Thanks.
ahead and introduce yourself. Thanks.
Yeah, thanks, Teresa. Thanks, Tamara. Hi, everybody. I'm Jack Cotrone. I am also with our non-point source pollution program. As Teresa mentioned, I am her counterpart in the program down here in our Warren District office, which is basically the Metro Detroit region. I'm really excited to be here today to talk to you guys about something we don't always look at in the context of MiCorps, at least on the stream side, which is a little bit of water chemistry, specifically chloride impairments in the Rouge River here in Southeast Michigan. This project is a really great example, not only of how the state can leverage volunteer collected monitoring data for our regulatory and management actions, but also how some different citizen science programs can work together to expand the types of data we can collect to support this work. Next slide, Tamara. So as I mentioned, we are focusing on chloride with this project. I think most folks on this call are aware of the impacts of chloride in the environment, but it's worth pointing out as a reminder just to highlight kind of how persistent and challenging of a problem this can be, particularly in urban areas. When we're talking about chlorides, we're talking about salt. There's a variety of sources of how these can get into the ecosystem and into our water resources, things like fertilizers, water softeners, dust suppression, but by far the most persistent and common, especially in our urban areas, is the application of road salt as a de-icer. This has a negative impact on our water resources when it gets into aquatic ecosystems. It is both chronically and acutely toxic to organisms like our macroinvertebrates and our fish. It also has a range of other impacts. It can be corrosive and degrade infrastructure. It can get into lakes and disrupt trophic state dynamics by harming aquatic vegetation or algal grazers, resulting in more harmful algal blooms. And it even affects the density of water, affecting things like spring and fall turnover in lakes and disrupting the ecosystem dynamics within those lakes. What makes chlorides and salts such a challenging pollutant is that once they're in the environment, they're very difficult to get out. For one, it's a dissolved constituent, so compared to, say, a suspended pollutant, it can't easily be filtered out. But even compared to other dissolved pollutants, things like nutrients or metals, it's not as regularly absorbed by a lot of vegetation and like best management practices or sorbed onto soil particles. So once it's in the environment, it can get into groundwater, it can get into streams, and it can be a very persistent pollutant. So the best way to prevent these impacts to our ecosystems is to stop chloride from getting into the environment in the first place. Next slide, Tamara. So with this issue being so important, especially where I work down here in Southeast Michigan in an urbanized area, we've got a lot of groups, both government and nonprofit agencies, looking at this problem. This project that I'm going to talk to you about today was led by partners at Friends of the Rouge. Friends of the Rouge is a nonprofit with the mission of restoring, protecting, and enhancing the Rouge River through stewardship, education, and collaboration. As I mentioned, it's a highly urbanized area, so we've got a tall task down here to protect this watershed. We've got very flashy hydrology. We have legacy contamination from past industrial activity, loss of habitat, channelization, combined sewer overflows. So the range of problems that we have to deal with here are extensive, and Friends of the Rouge is a tremendous partner in evaluating and addressing these issues. Friends of the Rouge has participated in the MiCorps program since 2001, so very early on. And they monitor spring and fall invertebrates as well as stoneflies at over 140 sites in the watershed, and they get to at least 40 of those sites a year. So a really tremendous long-term data set that we're able to leverage in some of the ways that Tamara and Teresa has discussed to figure out where we have water quality issues going on. And before I dive into this, I just want to give a huge shout out to our partners at Friends of the Rouge, of course, the volunteers, and then as well as the staff, Lauren and Sam and Sally, if you're on. You guys really knocked it out of the park with this one. So I'm really excited to show this off for the first time today, the work that you guys did through this grant. Next slide. So as I mentioned, we're focusing less on the bug and fish side of things and more on salt. So this effort actually leveraged another citizen science monitoring program that Friends of the Rouge is involved with, which is the Isaac Walton League of America's Salt Wash Program. It's a really awesome program that Isaac Walton League has. They will just distribute free chloride testing kits really to anyone who asks. And so a lot of watershed groups are able to obtain these testing kits as a free resource. And there's something that can be easily used by volunteers to start to get an idea of where we have chloride pollution in watersheds. So you can see there the method that's being used is the Hatch Quantab chloride test strip. Really accessible for volunteers. All you do is you dip a strip test right into a water sample. It gives you a reading that is in what are called Quantab units, which are then very easily converted into chlorides, and then that can help us to understand where we have chloride problems in a watershed. There's over 80 organizations nationwide that participate in this program, and all this data is available online through the Isaac Walton League's Clean Water Hub. You can see on the map there, we do have data for a number of places here in Michigan. Here in Southeast Michigan, of course, we have the Rouge River. We also have work up in the Clinton River done by the Clinton River Watershed Council and some data points down in the lower Huron as well. And this is something that we really do encourage you to do, and I know Tamara and the MiCorps program encourage you to do, is to incorporate the use of the Salt Watch test strips into your MiCorps volunteer sites. And Friends of the Rouge began doing this at every single one of their volunteer monitoring events beginning in 2020. So we have 3 data points at every site monitored for every year since 2020 on where we have chloride pollution. So a really valuable data set for us to take a look at. Next slide. At the same time, Friends of the Rouge was starting to dive into the chloride issue through the Isaac Walton League program. We at EGLE also started taking a bigger emphasis on issues of chloride and salt pollution with the development of our chloride and sulfate water quality values and implementation plan. Sulfates being the other major like sort of salt pollution that we look at. Like when we look at conductivity in the water, we're usually looking at chlorides and sulfates in the water. And so by development of these water quality standards, as Tamara already discussed, we can start to learn where we have impairments. So where the amount of chloride in the water is having an impact on the ecosystem and harming aquatic life. And so these standards were developed for chlorides, and you can see them on the top row of that table there. These are listed in micrograms per liter. I think the rest of the slides will be parts per million, so just go ahead and hack off 3 zeros there. But you see we have two standards. We have the chronic standard 150 parts per million. This is where we start to see impacts on things like behavior, growth, and reproduction of macroinvertebrates and fish. And then we have the acute standard, which is 640 parts per million, which is where we actually start to see mortality in these organisms from high levels of chloride. And then the third value there is the aquatic maximum value. That's just half of the acute value, kind of a factor of safety. So once we start seeing levels above that AMV, that's when we really start to worry about acute pollution from salts and chlorides in our water bodies. And where we have these impairments, that has implications for things like total maximum daily loads, permit requirements, and other management decisions throughout the water bodies. And you can see the maps there from the report. The chloride map is the one on the left. Our chloride pollutants tend to be in those urban areas, so Metro Detroit, Grand Rapids, Flint, Saginaw, Bay City, those areas. So we know we've got a pretty tricky problem that we got to start to tackle here. But before we can use our implementation plan to start making management and regulatory decisions, we need to know where we have a problem. And there's a lot of streams throughout the state. Most of them don't have long-term data sets for chlorides and salts. And so before we can start tackling this from a regulatory perspective, we need to start figuring out where impairments exist. Next slide. So where these two independent efforts sort of came together, like where all good things come together, was through a non-point source program grant from EGLE. This was from our Watershed Council grant program. So these are sort of our mini grants, capacity and support grants that we began doing in 2021 with a $600,000 annual allocation from the Michigan State Legislature to support water quality watershed councils and nonprofits who work to protect water quality. These grants can support a really wide variety of activities, which is one of the reasons I love them. Everything from education and outreach, watershed management planning, monitoring, capacity building, equipment and support training. So anything that all of the folks on the call who do the good work that you guys do to protect water quality here in our state, these grants can help you to do that. And they're usually done on a 1 year timeline with a $40,000 maximum award. So in 2023, when our RFP came out, Friends of the Rouge came to us at EGLE and said, hey, we've got this really cool data set of volunteer collected chloride data. And you can see the map on the right, all of the locations throughout the watershed where those chloride strip tests had been collected from beginning in 2020. And that map is showing data from 2020 through 2023. And they asked us, what can we use this for? We know this is good data. Can it help you? Is there any way we can use it to help try and solve some of these problems? And we said, well, as it turns out, we are also looking for more information on where we have problems with chlorides because we recently developed these chloride and sulfate water quality values. So maybe there's a way we could use a grant for Friends of the Rouge to go out and start assessing where some of these impairments are going on and seeing how the data that their volunteers collect might be able to be used to help us solve these problems both here in the Rouge and statewide. Next slide. So Friends of the Rouge did it advance? Tamara? Oh, now I'm seeing
Yeah,
it.
they
Perfect.
did.
Yeah, so Friends of the Rouge was successful in their proposal. And so we developed a scope of work that what kind of revolved around Friends of the Rouge going out and collecting data through an EGLE approved monitoring QAP. And at the core of this was collection of grab samples to analyze for chlorides across the watershed. This is kind of the gold standard when determining where chloride impairments exist, right? Getting a sample, sending it to a lab, having it analyzed, and then for making impairment decisions at EGLE, we need to have at least 4 samples at an individual site across the year that are above those impairment thresholds. So we said, let's go out to all the sites where you have volunteer data. Let's do lab and analytical and figure out where those impairments exist, but then compare that to your volunteer data to see if there might be more potential in the future for these strip tests to help us make these impairment determinations. So in addition to collecting those samples, we also collected information on chlorides through 3 other methods. Of course, the Quantab test strips, and then also using water quality meters. So the YSI meter to collect conductivity, which, as I mentioned, is often driven by the presence of chlorides in water. And then also the YSI meters now have a newer chloride sensor that will specifically show you chlorides in the water. So we wanted to kind of compare these three different methods and see how useful they might be and how volunteers might be able to employ them in the future. So then once we had the data, they were going to summarize and display and publicly share those findings on a map and a summary report, which is now available online. And then also use that data to develop management recommendations and next steps for solving issues of chloride impairment in the Rouge River. And then we also want to, like I said, I really love these grants because they have this capacity building component to them. So not only are we collecting this data, but Friends of the Rouge was able to purchase the equipment, the meters that they can now use for this type of monitoring work going forward. We funded some software training courses for the staff at Friends of the Rouge to learn to use ArcGIS Survey 123 for collecting the data in the field and then putting it into the map. And then we also had some capacity building in this grant by allowing Friends of the Rouge to hire and support two interns who would do the bulk of the work for the grab sample collection and analysis out in the field. You can see our two interns in the lower right there, Sarah and Lee. A little bit of serendipity, their initials spelled SALT, so our monitoring team became known as Team SALT. Next slide, Tamara. So once we had all of the scope in place, Friends of the Rouge, they went out in the watershed and they collected samples. 39 different sites throughout the Rouge River were monitored from January to June of 2024 using all of those monitoring methods that I described previously. And then that data was input into the Survey 123 form for use in developing mapping tools that could display some of this data. You can see there from some of our photos, the good old bucket on a rope collection method never fails. It's not rocket science, but a good way of efficiently collecting data at road stream crossings and other places. Most of our field photos, you can see Lauren and Sam there bundled up, collecting water quality data out there in the winter. Really important when you're looking at salt pollution because you want to capture the impact of that winter salt spreading season on the levels of chlorides in the water, and then see if there's places where it spikes when salt is being applied, or see if there's places in the summer and spring that still have high levels where we may have especially persistent problems where chlorides may have gotten into the groundwater or potentially even another source beyond just road salt. Next slide. So once we had all of our monitoring data, it was put together and compiled into a map. And so this map here it's available online on Friends of the Rouge's website. This is showing the grab sample results from throughout the watershed. As you can see, it doesn't look great. I mean, it's great data, but the results aren't great for the implications about water quality in the Rouge River. All of those red data points are areas where the mean values of all of the samples collected were above those chronic or acute impairment thresholds. So 35 out of 39 sites are at levels that could be considered impaired for chlorides in the Rouge. And of those 35, 25 of them were above those acute levels. So where we have particularly high levels that could be impacting aquatic life. So not looking great for the Rouge, but a very important data set to help us start tackling some of these problems. And this is also really important for us to consider when we're looking at other types of monitoring data. For example, the MiCorps invertebrate data. We might have places where we have low invertebrate scores, and even if the habitat or the hydrology looked pretty good, these sites with high chlorides might be kind of invisibly impacting the sorts of organisms that could live in these areas. So it's another really important bit of context that we can use when analyzing what our invertebrate communities look like and what our stream function is like in the Rouge River. Next slide. But this is the really exciting part of this for me was not just those grab results, but the comparison between the different analysis methods. And this is not all of our results here on the slides, it's just some highlights. But this is what really starts to get us excited, both at the department for how we might be able to use this data, and then for how our volunteers can really support this work going forward. Three big takeaways here. The first is in that top graph. In the Rouge, we have a really strong and consistent correlation between conductivity readings from the YSI and our chloride grab samples. That shows us there's a lot of potential for using conductivity as a proxy for chlorides. Generally speaking, it means what's driving our conductivity is chlorides more than sulfates, which is a common thing to see in urban areas. And that's helpful because a lot of direct water quality measurement tools come equipped with conductivity sensors, so your SONs, your YSIs. Really easy for someone, an organization or a volunteer to go out and just grab a quick data point. And this also opens up potential for continuous and real-time monitoring. So installing something like a Mayfly data logger in a stream equipped with a conductivity sensor, maybe at one of our problem sites to get a longer-term picture of how chloride changes throughout the year and trying to figure out where we may have sources. The second big takeaway, not as exciting, but still important to note, is we got really inconsistent results between the YSI chloride meter and the grab samples. Basically, what was going on is the values of that meter were just jumping all around. No matter how long the Friends of the Rouge held it in the sample, it wouldn't stabilize. And we thought it was an equipment error at first, but then even when we replaced the sensor, we found we were getting the same thing. And so they kind of had to ballpark the results from that chloride sensor, and that resulted in the inconsistency between that and the analytical samples. So at least at this point, if you're trying to do a meter type method for measuring chlorides, we might recommend trying to develop a conductivity relationship between conductivity and chlorides rather than using the YSI chloride. But lastly, and most exciting for this group is the data between the Quantab test strips and the chloride grabs, which is that bottom graph. You can see an almost perfect correlation, about as close as you're going to get, between what the strip tests were showing and what the grab samples were showing. At R squared there, what, 0.9909. So basically what that means is that this data that these volunteers were collecting over the years was a pretty darn accurate picture of what chlorides were looking like in the Rouge River. And so that opens up so many future possibilities for how we might be able to use volunteer data and to efficiently assess impairments in the Rouge.
We have two
So it's
minutes left,
that's
Jack.
all I need.
Okay, good.
So as far as next steps, here locally in the Rouge, we will use the grab sample data to evaluate chloride impairments at EGLE, and for potential inclusion in the 2026 integrated report on that impaired waters list that Tamara mentioned. And most likely, a lot of those sites, barring any unforeseen things in the data, will end up on the impaired waters list as of the 2026 integrated report. And that's that first step in finding better management solutions to solve these problems. I think we've definitely validated the importance of collecting this data with volunteers. So Friends of the Rouge will continue to use volunteer collected chloride data and expand their data set to help inform future work. And then both of our organizations can use this data to try and prioritize management solutions, zero in on sources with additional monitoring, find voluntary actions to address these issues in watershed management plans, or through regulatory solutions going forward, and then targeting education and outreach in places where we have private or residential impacts from chlorides. And then finally, last slide, Tamara. Statewide, we will continue to encourage adoption of chloride test strips for MiCorps volunteers because I think there's a lot of potential to use this to make impairment decisions throughout the state, and exploring opportunities for using that strip test data for determining impairments in other watersheds. Like I said, down here, we've got data in the Clinton and the Huron that we might be able to use to start making some of these decisions. And then once we have this data set built out, it can start informing how EGLE uses the data to support the chloride, sulfate, and water quality value implementation plans and associated actions. And I think this just nicely highlights the potential for water quality data collected by volunteers in making regulatory and management decisions. And so beyond just chlorides, I think we could look for other ways that we might be able to leverage MiCorps or other data in helping us do our work here at EGLE. So that's the last slide. The final page just has a few links to all of this data on Friends of the Rouge's website, as well as info on the Isaac Walton League, Salt Watch, our Watershed Council grant program, info on the chloride and sulfate implementation plan. And then lastly, I want to highlight that Friends of the Rouge has a stonefly search coming up on January 24th. At 10 o'clock. If you're interested in participating in that, get in touch with Friends of the Rouge with Lauren or Sam or someone over there, and you can bundle up and go out there and look for bugs that are helping tell us about the quality of water in the Rouge River. So thanks.